Okay, welcome once again to the Science Circle. And thank you for coming out during the weekend, whatever time and day it is for you. One of my personal joys of these presentations is that we often have such a diverse audience from all over the world, and we're able to come together to share common interests. If you're new to our presentations, the speaker generally uses voice and the audience chats in text. I'm going to present this in a little different way because than I have in the past, because I actually have a script and I'm going to follow it because there's a lot of material, and I'll make it available to Chantel and Jess or others if they want so they can post it. As always, I encourage chatter in text. Participants often post links and other information on subjects we present, and I welcome that. This is an interactive venue. I hear we have some experts in the audience, so as I tell my students, please correct me if I'm incorrect or if you see things differently than I present them. I've also not rehearsed this, so I'll watch my time because we like to keep these presentations to an hour or so, and with questions and comments, and I hope mine fits in and it's not too long. Okay, I've titled my topic today, Voyager and Cassini, Where No One Has Gone Before. Because the space missions to the outer reaches of the solar system are my main focus, but this is also a personal journey because much like computer technology, which I teach at the university, I was there for the beginning of both these incredible stories. Both have become part of my life and my dreams and the visions of others who have shaped the reality of our lives today. Reality begins with a vision. Back when I was growing up, there seemed to be three main themes that dominated at times, much like today: politics, our social lives, and technology. The space program actually began as a quasi-military competition between the Soviet Union and the United States during the height of the Cold War. Demonstrating that your rocket could carry a satellite or a person into space was proof that it could also carry a nuclear warhead to anywhere on Earth. North Korea today is just a little more open about it. But some had other visions. The Reverend Dr. Martin Luther King Jr. dreamed of a time with less racism and more civil and economic opportunities. While we've made some strides in that area, one of my life's disappointments is that we still have so far to go to make his dream a reality. Dr. Wernher von Braun, influenced by science fiction stories of spaceflight, dreamed of building a rocket that could enable us to explore worlds. Credited with inventing the V-2 rocket in World War II, he's also responsible for the Saturn V rocket that enabled humans to reach the moon. U.S. President John F. Kennedy, who served during the early days of the space program when I was in school, gave us another vision of our technology with his challenge to land a man on the moon within the decade. Reality begins with a vision, and visions spark our imagination. Star Trek began as a science fiction television series of the mid-1960s and continues today with movies and a new series. While the series of the 21st century darkened in tone, the original series was hopeful and boldly went when no one had gone before. In several ways, notably in the makeup of the crew, a science officer was an alien. The communications officer was a black female. The helmsman was Japanese, and the navigation officer was Russian. One influential science fiction book and movie of the times was Hello, Hal, yes, was 2001: A Space Odyssey. That movie envisioned where the manned space program may have been by the turn of the century. It also featured Hal, an artificial intelligence that ran the ship. The author, Arthur C. Clarke, would continue the series with 3 more books centered around exploration and colonization of the moons of Jupiter. Just like science fiction stories has sparked the imagination of Wernher von Braun and others, Star Trek had a strong influence on my generation. For example, the cell phone of today, as I depict on the right in the slide, Even the pop-up lid of earlier versions from the 1990s, early 2000s is a reality made possible by the vision of Star Trek's communicator in the 1960s. Back in the 1960s, when computers were room-sized and millions of times less powerful than your smartphone, and no one had invented a way for them to communicate, Joseph Licklider dreamed of a global network people could use to share ideas. In 1969, 4 computers were connected to begin what we call the Internet today. Back on Earth, we realized that until we had warp drive and could travel among the stars, that we had to find ways to create a rocket that could get us off the Earth. The V-2 rocket of World War II reached speeds of 5,700 kilometers per hour and a height of 88 kilometers. To get in orbit, though, a rocket must reach 27,000 kilometers per hour. To escape Earth's gravity and reach the moon, 40,000 kilometers per hour. To get to Jupiter and beyond, you had to go faster or find a way to propel a spacecraft forward. Both the Soviet Union and the U.S. launched animals and rockets starting in the early 1950s. After the first successful object to orbit the Earth, the satellite Sputnik, was launched in 1957, Laika became the first canine to orbit the Earth in the same year, followed by Russian Yuri Gagarin, the first human in orbit. In 1961, American John Glenn in 1962, and Valentina Tereshkova, the first woman in space in 1963. The year after this, a NASA JPL scientist named Gary Flandreau was making calculations on the movements of the outer planets and discovered in the 1970s that they would be aligned so a spacecraft could reach Jupiter if it could use its enormous gravity to slingshot the craft into outer planets and beyond. The alignment would not occur again for 175 years, so he played it up with NASA. And NASA promoted it as the Great Tour. Well, eventually humans made it into space. Besides the political and organizational issues, one of the primary reasons the U.S. was able to send people to the moon was the Saturn V rocket. The Soviets at the time did not have an equivalent. Since the first moon rockets and landing in 1969, when I was in high school, we have decided for political and economic reasons to stick around Earth, culminating in joint space programs like the International Space Program. Ironically, it is Russian rockets today that send astronauts up to it, since the U.S. decided it has other priorities and the space shuttle program was scrapped. Future manned missions are planned, though. The Chinese, Russians, and Japanese have plans to land on the moon again in the 2030s, while some commercial companies have plans for earlier ventures to the moon and Mars. Yeah, Laika. Ariane, I think, was writing Laika there. Sending a person into space requires a lot of equipment and other support and has big psychological consequences as well. But not so a spacecraft with scientific instruments. Even before the push to land a person on the moon was fulfilled, missions to the planets were already a reality, with crafts visiting the moon, Venus, Mercury, and Mars. The vision to visit the outer planets became reality with the Pioneer missions. Back when I was in college, Pioneer 10 launched on an ICBM rocket in 1972 on its way to Jupiter. Just as the manned missions to the moon were ending, the missions to the outer solar system, envisioned by Gary Flandreau, were becoming a reality. The primary mission of the Pioneers was to explore the way for later missions and to fly past Saturn's moon Titan. Pioneer 11 made it to Saturn and discovered that Titan, which is about 50% larger than the Earth's moon, had a dense atmosphere, the only moon in our solar system known to have one. Knowing that they'd be able to leave the solar system, each of these spacecrafts has a plaque on board. It contains an image of humans besides the spacecraft to show scale, a depiction of the solar system and the Pioneer's flight path through it, and how to find the solar system in reference to about a dozen pulsars in our area. The last we heard from the Pioneer spacecraft was in 2003. They're still headed out of the solar system, but they're a lot slower than the Voyager spacecraft, so actually Voyager passed them up in distance from the sun in the 2000s, though the spacecraft are all headed in different directions out of the solar system. Voyager launched in 1977 when I was a research biochemist at the University of Hawaii. The primary mission of the Voyager spacecraft was to explore both Jupiter and Saturn, but also to visit Saturn's moon Titan, and then to proceed to the outer planets if possible. In 1979, when I was in the Navy, Voyager 1 reached Jupiter. In the 1970s, computers were still primitive compared to today. Voyager's computer technology in the 1970s was vintage by any standards today. Each craft had 6 computers to control its many scientific instruments, cameras, and navigation, and the total memory was only 32 kilobytes out of all 6 computers, about the same space that's taken up by a logo on a web page today. The images that Voyager sent back were incredible. The outer planets and their moons were no longer fuzzy disks, but startlingly new and wondrous and dynamic entities. Among their various discoveries was that the moons were not dead bodies either. Jupiter's moon Io was especially active geologically and has the only known active volcanoes outside the Earth. Closer views of Titan showed it had geological features under a thick atmosphere made of methane and ethane and other molecules that created organic smog, including hints of hydrocarbon lakes, the only known water features outside Earth. The Voyagers also discovered that the outer planets were not uninteresting themselves. Jupiter and Saturn both have swirling storms and lightning. Jupiter's red spot is believed to be a hurricane 3 times the size of the Earth, which has lasted for at least 300 years. Voyager 2 made it out to Neptune in 1989 and was greeted by we were greeted by another dynamic gas giants with swirling storms. On the way out to the outer reaches of the solar system, the Voyager spacecraft explored Earth's magnetic field in a rehearsal of the instruments it would use when they got to Jupiter and beyond. The Voyagers were 2 of many spacecraft who have found that space is not so empty as we think. It's just that we can only see such a small portion of the electromagnetic spectrum with our eyes, but space is brilliant in other parts of the spectrum, and it contains fast-moving solar particles and other particles from planets. Each Voyager also carries a message to possible intelligent life that it might encounter years from now. The Voyagers each carry a golden phonograph record containing 115 images of Earth, sounds of nature, and greetings in 55 languages. The Galileo spacecraft launched in 1989 with a targeted mission of visiting Jupiter's moons. Laserdisc? Yeah. However, I suppose that if they are smart enough to figure out what the grooves on the phonograph record phonograph record are like and how to play them. We didn't provide any instructions, I suppose. Okay, the Galileo spacecraft launched in 1989 with a targeted mission of visiting Jupiter's moons. The photos it took were breathtaking. Each moon is distinctly different and complex, and Europa was discovered to have a newly created surface made of water ice. And it detected salt water plumes from cracks in the planet, and it has a thin atmosphere of oxygen. NASA is considering a Europa Explorer mission in the 2020s that would confirm this. The joint NASA, ESA, and ASA, that is the Indian Space Agency, Cassini Spacecraft launched in 1997, within months of my starting to teach at the university. Its military-hardened computer had 1 megabyte of memory, and it carried a DVD with 600,000 signatures from 81 countries. Cassini entered orbit around Saturn in 2004. It discovered that Saturn also has violent storms and winds that rage at 1,800 kilometers per hour. The North Pole of Saturn is distinctly hexagonal in shape, and it contains a huge hurricane at its center that rotates at 560 kilometers per hour. The Cassini spacecraft contained a separate module named Huygens, excuse me, I'm butchering the name, that landed on Titan in 2005. What it discovered on the way down, which was the first landing on another moon besides Earth's, was astounding. Titan's smoggy atmosphere was hiding mountains composed of rock and water ice, and rivers and large lakes composed of methane and ethane that creates Titan's atmosphere. Now bear in mind that the temperature of Titan is minus 179 degrees Celsius, so water is as hard as rock there, but it's the first place with running liquid on any surface and looks like that outside the Earth and looks much like a colder version of parts of the Earth. On September 15th, 2017, you may have been there, mission controllers decided to make Cassini part of Saturn, much as the Galileo spacecraft burned up in Jupiter's atmosphere for the same reason. The reason being is that Saturn's moon, Enceladus, is also thought to have a liquid ocean, a water ocean under its crust, with volcanic vents like in Earth's steeped oceans that keep the water at a temperature that could support ocean life on Earth. We now know that microbes can survive for long periods in outer space, and we don't want to risk Galileo or Cassini possibly contaminating a moon with other life on it. The New Horizons spacecraft launched in 2006 and rendezvoused with Pluto in 2015. Again, Pluto did not disappoint. Rather than a cold, dead planet, even Pluto, small little minor planet, only 1/6 the mass of Earth's moon, and varying in orbit from 4 to 7 billion kilometers from the Sun, showed amazing structures. It's one of the most contrasting bodies in the solar system. Pluto's surface is 98% nitrogen ice, but it has a thin atmosphere, traces of methane and carbon monoxide, and whole mountains of water ice. New Horizons discovered signs of glaciers and snow and frozen basins with polygonal cells of blocks of water ice protruding from them, much like you might find up in the north of the Earth. Pluto is but one of many large objects in the Kuiper Belt, and the New Horizons spacecraft is now headed to another mini-planet out there and should arrive in 2019, so stand by. The mission of the Voyager spacecraft is far from over. Voyager 1 became the first Earth orbit to leave the solar system in 2012, but will lose power to communicate in the 2030s. I would love to still have power then myself. I'll be in my 80s then. In the meantime, the spacecraft is still measuring the boundaries of our solar system. In 2005 and 2008, Voyager 1 and 2 respectively reached the area of termination shock, which is the area where the particles of the solar wind finally slow to below the speed of sound and kind of create a buffeting area, much like aircraft on Earth that reach the speed of sound. In 2013, Voyager 1 experienced particles that would indicate it has finally left our solar system, the first Earth object to do so. As I tell my students, the city we live in is only a dot on the map, and I encourage them to explore the bigger world. This slide shows a map of the few dozen stars in our solar neighborhood in the middle, about 600 light years out in the region of the galaxy we live in on the left, and finally a depiction of our Milky Way on the right. On scale, consider that the nearest star is 4.3 light years away. I'm trying to remember how long it would take Voyager to reach that distance, but a very long time. And that even the area on the left would only be a small dot on the map of the Milky Way to the right that's 100 to 180,000 light years across and contains between 100 and 400 billion stars. We still have much to discover. And I just discovered, since I didn't rehearse this, that I completed the whole thing in about 20 minutes. So what I would like to do is perhaps back up to whatever slides you want. Yeah, I know. I tend to talk fast, perhaps. A lot of material I'd like to back up or discuss parts of this, or invite the audience to share things they know about these missions, or how perhaps the space missions have impacted on their lives. I know it's impacted on my life strongly. I have found that, hey, good, thank you. For me, as I mentioned in the 1960s, one of my disappointments as I'm nearing my 70s is that we have not lived up to some of the social life realizations that we started in the 60s. And yet the space missions never fail to surprise us, never fail to disappoint, or never fail to provide us fantastic new views of lives beyond, or worlds beyond ours. Also in science fiction, if you discount all the military aspects of some of the Star Wars or even Star Trek, it is about hope. At least Star Trek used to be, about crews of diversity, and about how people, if they got together in a federation or respected others, a lot of the themes would be able to survive even Third World War as they depicted in Star Trek. Okay, do I think that they found the aliens and keeping it from us? Well, first of all, I think that aliens are probably smarter than us, and it's very possible, like in the Prime Directive of Star Trek, that we're just too darn primitive, and we're probably going to blow ourselves up before it's worth saying hi. And if I don't want to be that pessimistic, then they're just probably watching us until we prove that we're worth talking to. Ha ha. Let's see. Which moons do you think are the most promising for us to investigate for life? Well, there are two. Yeah, there are two. One is Europa. The other is Enceladus. Now, Enceladus is around Saturn. Europa is around Jupiter. These are not moons that you're going to land on and plant a flag and say, you know, hi and that kind of stuff, probably, because they're very active. The surface area, you're going to have to pick a good place for it if you want to keep your spacecraft intact. And they're very, very cold on the surface. But underneath, if you can send a probe, much like we have the little submarines and stuff, if you can get through those cracks, if you can kind of dig a hole in the ice where the cracks are and send a little probe down there, it would probably be amazing, perhaps, what we discover. At least we could discover, at the very least, what the temperature of the water is underneath and what is in the water. And I wouldn't be a bit surprised if there was life. Frankly, in my lifetime, that would be the most exciting discovery ever. To know that Earth is not the best we can do as far as life goes. Just imagine, you know, billions and billions of galaxies and hundreds of billions of stars and thousands of planets just within our reach. or at least within our sight, and Earth is about as good as we can do? I don't think so. I mean, there's great stuff on Earth and great life and that sort of thing, but I'd love to see other versions of life. Anyone else out there? Oh, okay. Well, I haven't listened to that one, but I will do so. If anyone else wants to chime in here. Anyone want to see earlier slides? I can go backwards. There we go. Okay, it's rezzing in, at least on my screen. Taking a minute. Okay, what's new? If you, for you guys, if you don't live, eat, and breathe this like I do, I'm not a space scientist, but I'm an amateur, lots of stuff, and so I like to explore and use my imagination and pretend I'm out there and stuff. And yeah, that's probably why I play video games too. You know, they're new worlds and new lives and stuff. I like mine. It's exciting. I do too much. I'm too busy. And I've lived a lot and been to 42 countries and blah, 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 and seen a lot of people. And it's been very exciting, but I'd love to go somewhere else. If I had a 50-50 chance of, say, living to go to Mars, I'd probably take it. Well, now that's a very good question. They've been exploring that. Obviously, we know that even on Earth, it hasn't been that recently that we've discovered life that does not breathe oxygen. For example, down by the vents in the bottom of the sea, there's life that keeps just on the edge of those very, very, very hot vents well above boiling point, and they use sulfur instead of oxygen for metabolism. And so I don't know about silicon life. We don't have silicon life on Earth that we know, and so it's all carbon-based. But even at that, we have found so many yet. Even at that, we have found so many planets, and even in our solar system that have, we don't have to go looking for too exotic stuff. We have, yeah, there you go. Tell me if you find anything. But we don't have to go looking for too exotic stuff. We have water ice. We have water, liquid water, under the crust of Europa and Enceladus. And it's warm. It's not at minus 179 degrees. It's warm. We've seen planets around other stars that we could live on, including, by the way, the closest one to us. If you know your astronomy a bit, Alpha Centauri, which is 4.3 light years away, which means that we'd have to get a pretty fast spacecraft if we want to do it in our lifetime. But in theory, we could get there. It has 3 little stars around it, and one of them, Proxima Centauri, I think it is, has a planet which looks pretty darn homey. And one day we'll have to go out there and check it out. There is has anyone heard of, by the way, the little spacecraft that could actually get there in, say, let's see, what is it, 20 years? There's little bitty things that are about the size of little, I don't know, smaller in your hand, and they would send them out at about 30% of the speed of light by laser beam and send thousands of them, and their entire mission would simply be to take pictures and maybe some sensing and send it back to Earth. Of course, it would take a little longer, and it would be our kids or grandkids that would get these things. Yeah, very cool. And it's current technology. It's not like it's something like warp drive that we have to figure out. So we could actually find out about some planets outside our solar system then. I'm kind of excited that perhaps we can go to Europa, except, of course, Arthur C. Clarke said don't do that back in his Space Odyssey books, because it may contain life. We'll see, but I'd love to find that out. Yeah, although I got to tell you, the book The Martian and then the movie, which was very well done because it did have a lot of science in it. And they've actually found, I think, that you could actually probably grow potatoes up there, is I wouldn't mind being left alone. Hey, even if there wasn't a happy ending, is at least I've lived long enough that I would love to have some kind of adventure like that. My goodness. Yeah, sounds like a nice sabbatical. Okay, let's see. There are claims that we can tell that dark matter is more common than baryonic matter. Baryonic matter being what we can actually sense and that interacts with each other, for those that are not particle physicists. Since we don't know what the number of stars in our own galaxy to a factor of 4, how are we confident about the amount of baryonic matter? Well, I'll tell you what, it's not off topic, because nothing's off topic in Science Circle, that has to do with science. And so, does everybody know why we know that there's dark matter? Anyone out there? I'll give a real quick tutorial. Okay. This is just the first thing that they discovered. Is there was and I'm trying to remember the name of the lady, but she was a scientist back at the end of the 1970s. Yeah, okay, baryonic matter is, basically baryonic matter is the stuff that we think of as matter, and it wasn't until the end of the 1990s that we thought that was all that was out there. And now we know that it only composed about 5% of our universe, and that we've got, I think it's something like, 60% that's dark energy, and nearly 40% that's dark matter. And the reason we know that there's dark matter out there is, generally, if you have a galaxy and you spin it around at once every 250 million years, which is what our galaxy does, and our sun is going around it and goes once orbit in 250 million years, is that the planet should, the ones near the center to that big million sun black hole that's in the center of our Milky Way, they should be going faster than the stars on the outside. Okay, that's basic physics, is that, and that's what happens with our spacecraft. If you're in orbit, like say in the International Space Station, you're going 17,000 miles an hour, but the Earth is only going 1,000 miles an hour. So how many, for you guys out there, how many sunrises and sunsets do the people on the International Space Station experience every day? Or how often do they experience it? In fact, I forget in Second Life, how often is how often is day and night in Second Life? Isn't it like 4 hours or something? I always put my sun to midday so I don't have to worry about that, but anyone know? In any case, every 90 minutes. So if you like sunrises and sunsets and you're not busy as all get out, yeah, there you go. And you're not busy as all get out like the people on the space station, and you're able to look out the window and view the sunrise and sunset. You get to do it every hour and a half. How cool. However, the farther out a spacecraft is, and they're only, say, 100 miles up, between 100 and 200 miles. Okay, so, but further out, the spacecraft are still going like crazy around the Earth, but in comparison to the Earth, because of the diameter of the orbit, they don't have to go quite as fast. And so by the time you get to 23,200, about 25,000 miles out, you've got a spot where the spacecraft are going the same speed relative to the surface of the Earth, and that's what's called geostationary orbit. That is, if you look up, you basically see the spacecraft overhead, and it appears to be going around at the same speed as the Earth. Now, that's what should happen with a galaxy. The problem is that all of the solar systems, including our own and the ones near, spin around the galaxy almost as if it were a disk. Isn't that amazing? In the 1990s, that's what they discovered, end of the 1990s. So what that means is the only way to make that is that the parts of the galaxy we can see, the 400 or the 100 to 400 billion stars and all the gas, is not all of the galaxy. We actually have somewhere between 1 trillion or 2 trillion stars of mass of the galaxy, and that's what helps it all go around almost like a disk. And most of that is dark matter that we cannot see. And they've also found that other galaxies exhibit the same patterns, and that's why they clump together, and why we have our local cluster and all this stuff like that. And so dark matter was discovered. Isn't that amazing that only 20 years ago we just began to realize that 95% of our universe is not stuff we even know about, and we still have to find out about it. Isn't that cool? We're still learning stuff. Okay, that's a very long-winded explanation for a question. Any other questions, comments, experiences you had with the space program? I'll go backwards on my slides. Anywhere you want to travel? Sure. What could be crazier than this place? Okay. Hey, I don't know if I've ever heard you. Yeah, of course I have, probably.
Can you all hear me? Hello? Yes, okay, I'm good. All right, so I've had a crazy idea that I've been sort of scared to publish or put out in the scientific community for fear that people laugh at me, but I figured this is a great community to try and share something like. And the idea I had is very simple. I'm a paleontologist, but I like thinking about astronomy stuff as well. And the question is this: if you look at the evolutionary sequences of most organisms on Earth, you find that as you go through time, organisms' descendants tend to look like the children. Steve Gould at Harvard University actually wrote a book, Neoteny and Phylogeny, and he argued in the book that this process is known as Paedo Morphosis, where descendants over long evolutionary time start to resemble the children. So I made a sort of crazy, weird prediction that let's suppose planets or solar systems had formed before the Earth or our solar system, before the 4.56 billion years that Virginia Tech is talking about these days. And you had a civilization that got started before then, and they went to the next evolutionary step. If they're following what we observe in just about every other organism, talking invertebrates, vertebrates, plants, their descendants would look like the children. So what do our children look like? When they first come out, they've got big heads, they've got big bulging eyes, diminutive limbs. And it's sort of ironic at all the crazy extraterrestrial reports. You think of little green men are big heads, bulging eyes, diminutive limbs, and so on. So I'm just wondering if there's anything to that. And if anybody can find me a little green alien, that might be the way to test this crazy theory. But I'll just throw it out there that it's interesting that that prediction sort of falls in with evolutionary theory that I've seen.
Yeah, I've actually heard the same thing as that about the little kid with the big head sort of thing. By the way, I only caught about half of yours because I realized I didn't have my sound up. Boo. Okay, but I'm glad you presented that. Everybody else heard that. Oh, cool. Is that what it's called? I love it. Okay. Hey, at this point, if anyone else wants to talk on voice, please feel free. I didn't realize my presentation would be as quick. Yeah, like penetration. Pediatrician. Well, that's an interesting paradox in itself. If there are other planets and civilizations out there, which of course there must be, at least according to my logic, is why haven't we discovered them? And the only reason I can think of is they're just not interested in us. Or we don't know their language or whatever. You know, if we hadn't discovered radio waves, we wouldn't know that there's radio waves all over the place, and that's only been 100 years. Hey, I was told that there might be a teacher or NASA person out there. Anything you can add? Well, my understanding is that they're pretty certain about the age of the universe. In fact, they've actually got it back to like 13.678 billion years, based on physics and our understanding of what everything we've seen out there. Um, but of course, we don't know everything. Aliens, hostile or friendly? I think that's, I'm trying to remember the psychological name for that. It's kind of like what Di was saying about the little kids. Paedo is, I think we tend to do what's called, anybody a psychologist out there? In other words, you tend to place yourself on others. And it's the name for that. And the idea is that I think the whole idea of us thinking that aliens might be violent is because we're violent. Okay, and we think, well, other people might be, yeah, projection, perfect, excellent, okay, projection. So just because we're violent and we haven't figured out how to live with each other doesn't mean that more advanced races, which pretty much, or aliens, I mean, is pretty much, I don't think they would be, frankly. Because, you know, how did they get along? How did they survive? How did they get to other planets if they couldn't? This is not a one nation thing. I'm very glad we have joint projects like we do now. I love to watch things like the Olympics, provided they're not too political. I love the space program because it's one of the only places where we actually do stuff together, even though it can be politicized in the economy and stuff. Hey, by the way, okay, how much did Cassini, I don't have my notes in front of me, but how much does Cassini cost? Anybody? Take a guess. Wild guess. Yeah, actually 3 billion over about 30 years or so. Now, 3 billion, yeah, we can say oh, but 3 billion is about what it takes to clean up the garbage in the United States in a year. 3 billion would fund the U.S. military for, let's see, it's 9 days, I think. 3 billion would, would fund the U.S. military for about 9 days. It would feed everybody in Africa for, I think, around a week, I think. Something like that. In other words, if you spread yourself too thin on some of these, 3 billion is not. Some of these space programs, in fact, all of the space programs ever, have provided us an enormous return in terms of technology, in terms of just plain sheer wonderment and awe about worlds. It's made us realize that we're not all there is out there. Makes us feel small and humble, and that's a good thing sometimes. All of those are my thoughts anyway. Anyone else have other thoughts? Yeah, I actually gave I could dig it up here, but I actually gave my class, I have a introductory computer class, and I gave them 50 things that the space program has given us. Everything from, I think it is, EKGs and prosthetic limbs and Velcro, and it's amazing how many types of things that we have from the space program. Yeah, there we go. I mean, I could dig out my list, but but basically the idea is that the space program. But the problem with the space program, and I don't see a problem other than an investment that paid off very well. That's correct, as far as I'm concerned. And the idea is we don't always have to. It's much like the pioneers, the earlier explorers, these names that Voyagers, that we give to the space program, spaceships themselves, is that people used to say, okay, let's just go do this and go out there. And yeah, okay, it's risky, but hey, think of the discoveries that we have. Yeah, exactly. The non-leaking ballpoint tip pen that you can hold upside down, all that stuff. Those are just tiny little things. But the discovery, the ideas, all of what comes about it, the imagination, all of that has come about from the space program. Okay, this is kind of different. We don't usually have this much time to talk. Okay, there you go. Thank you. Good. Yeah, they do. Think the imaginations about what could be beyond. We have to have that. That's the whole thing that I mentioned at the very beginning, is that reality starts with a vision, and visions begat reality. I mean, that's how it works. You have to think outside. I hate to use the word outside the box. You have to think beyond what you're doing to be able to do this. Yeah, now forwards and backwards is kind of a Western idea. In fact, it's somewhat of a Judeo-Christian type of idea. But we at least do something different and expand and outside of us. Sometimes I'm not sure we're going forwards in some areas. I think we're learning more. Well, I don't know. I think my dog looks up at the stars every once in a while. I think we're kind of like dogs. Maybe to aliens, that's what we are. Just kind of cute little pets. Hey, thanks to Chantel for the nice props here. We got Cassini up to your left, and the Voyager spacecraft up to the right in real size. Notice the antennas, the communications channels, parts of them. Yeah, okay. And, okay, you just mentioned high school students. I think it's extremely important to, first of all, the reason why I did this the way I did was I wanted to provide context. Okay, in other words, how, why did we decide to go to these places? Why did we spend $1 billion here or $1 billion there? Why was it supported? Part of it is that we want to learn more about here. We're just discovering things. Like I said, we just discovered not long ago about life in the oceans that is not even oxygen related. They don't even use oxygen. How could that be discovered? How could we know about those sorts of things? We don't know about much of the species on Earth. We're probably going to wipe them out before we even know about them. Yeah, and Damien, of course, the commercial companies like SpaceX have already many, many times landed their rocket back on a platform and proven that it could work. So yeah, and of course, what we really need to do is it takes a lot of oomph to get off the Earth. So what we need to do is to start building stuff out in space. A nice big spaceship, and then you could build anything you want. Use materials from the moon, or go get a moon base. Use all the stuff up there. I mean, they have most of the stuff we need up there to build stuff, including oxygen from ice we found in caves on the moon, or at least we've detected. All of that sort of stuff. Water, oxygen, that sort of thing. So we need to build something that's outside the Earth, and we need to be think in terms of long term, not what ROI, rate of return, are we going to get in 5 years that's going to pay the billionaires off, but what we can do as a species in 5, 10, 30 years. That's part of, I think, our problem, and part of the thing with like global warming and stuff is we just don't see ahead, or we don't see how it can benefit us right now in our little tiny, infinitesimally small lifetimes. I don't know about rare earth metals on the moon. I suppose there are, just the same as, rare earth here, although we don't need a lot of them. I mean, the bulk materials, I think, are already there. Mining asteroids for precious metals. Of course, remember that if you bring back 1 billion tons of gold or whatever that you're going to throw, or even any metal that's going to throw the economy into a tizzy. Okay, I'm gonna wrap up this thing pretty soon. Of course, everybody, yep, neodymium, neodymium, all kinds of good stuff. Um, yeah, thank you. I'm glad you could come. Thank you. I should have probably talked slower than I did. Hey, I do have, I will give the slides to anyone who wants them, and also the script to Chantal, Jess, others. Thank you very much for being able to come. You can always stay for as long as you want. I think Science Circle's open 24/7. This is cool stuff. Really is. And it's even better that there's people here that share this common interest in this from all over the world. Think beyond yourself. This is great. We have so much to discover. Makes life interesting. And if you can, of course, get out there and talk to real people from all over the place. We're doing it here. Okay, folks, take care. Cool.